Hello, hello. So nice to see everyone here today. So, now I will grant this is the only illustration I got away with in this talk because we definitely want to be a little bit more technical for this one. So, just start out with, who am I? Well, my name is Brandon. I love Ruby, apparently enough to come to Japan and speak to all you lovely people about it and share some of that love here with you today. Now, that said, shall we go ahead and get started then? So on the subject of ASTs, briefly, what are they and where are we today at a high level? So when you see this text, what do you see around this audience? Do you see words that make sentences? Do you see characters? Do you see strange symbols? To anyone outside of Ruby, very likely they just see a bunch of text. They don't see anything of value. But to us, well, we see something different. We see that someone is monkey patching enumerable again and trying to sneak in a method which might have gotten rejected. We see a method that takes a block and uses map and tally to count objects by the result of that block, and we can see the output below it with a comment. That's because as poor as we might be at it, we are all Ruby interpreters. We see Ruby as code, symbols, tokens, expressions, and more. It's not just text to us. It has distinct meaning. And that, to me, is what ASTs are. Symbolized meaning in a way that we can programmatically interact with it and do wondrous things on top of it. Now, certainly, I would not trust a Brandon Ruby interpreter, but much smarter people than I have created ways to translate these blobs of text that we call Ruby further into ASTs that we can do something with. And those are called parsers. So how does one go from Ruby code to an AST? Well, there are a few parsers which get us there. But before I get too much into that, there are some very smart people, as prior mentioned, that have spoken a lot on this. And at the bottom of these pages, you can all find QR codes to any further links or other resources. I've additionally linked that in the Discord channel. So Bibatsov here, who you might know as the person behind RubyKaigi, has done an incredible job of summarizing a lot of these things. Now, mine is going to be far higher level and is going to synthesize a lot of these posts, but we'll cover the three major ones he does. So we start off with Ripper, which is built into Ruby core itself. Now, back in 2019, and even semi-recently, it was considered the de facto Ruby parser and is actively maintained by the core team. But as you can see from that output, that's very hard to interact with. It's a lot of arrays, a lot of nested structure. I'm still not sure to this day what all those nils are exactly for. I'm sure someone smarter than me could explain this. But programmatically, it was very difficult to work with, but it did give us our first actual area to where we could interact with ASTs and do something. And RubyKaigi and a lot of original tooling was built on top of this. So being that it's in the core, it's tied to MRI. It's very fast and very accurate to Ruby, which means that there's no drift if someone happens to make a patch commit and someone happens to update this. The problem is it can be difficult to approach, and it really doesn't have a lot of documentation which will guide you through these things, which means it's not easy to contribute to, and a lot of the metadata and things you have to interact with are in line in that code. While usable, it was not approachable to everyday Ruby users. In fact, most of the time you had to be very advanced to be able to use it. Which is why whenever the white quark parser came up, it was a very different approach to ASTs and a very novel implementation which allowed a lot of tooling that you see today to really take off. It took a page from Lisp-like languages and formatted in terms of S expressions with rich metadata and a syntax which is far more approachable to your everyday Rubyist. In fact, RubyKaigi really took off during this time period because it gave it a far more accessible syntax that not only the core maintainers of RubyKaigi who spend all day, every day working with ASTs, but people like you or me who really don't spend that much time in it are now able to actually do something on top of the tooling. And we'll get more into that in a second. But the single core feature of this, which really changed the foundation and the shape of tooling in Ruby, LSPs, all this stuff is predicated on top of a lot of this, is Tree Rewriter. Now, Tree Rewriter allows us to rewrite segments of an AST by searching for it and then changing those. But also, the fascinating part of this is that if you happen to make multiple changes, what if they change the same code? What if they do so in a different order? What happens if they run into each other? Tree Rewriter gave us a lot of syntax and ability to deal with these scenarios to where we would not have these issues, which allowed tools like RubyKaigi, which rely on several rules, probably hundreds to probably 500 in some larger code bases, to very accurately be able to do this. And if they run into each other, you will get a warning, which was incredibly, incredibly useful, and quite frankly is a lot of the basis of this talk. So making a tool which was easier to understand and work with opened the doors to everyday Ruby. It was very well documented. All the nodes, all the syntax, all the features of working with it were very clearly documented in either the code itself or in additional documentation wikis. It was easy to work with and on, and it works with all Ruby implementations, which is something that you didn't get with Ripper. It was able to work with JRuby and some of the other implementations. Tree rewriter, of course, was a very novel concept whenever it came out, and it has that rich metadata. But one of the other things is that this was one of the first to allow for pattern matching of structural decomposition of how do we represent this in a way which we can match shapes against it, which will come in very handy later. Now, there are some cons to this, which are Ripper, very, very, very fast because it was written in C, it was written in core Ruby. Parser, or White Quark, is built on top of it, so it's not quite as fast, but for tooling, you don't really need that. You just need to be able to represent it and do something with it. There was a slight period of stagnation where the maintainers had switched out a little bit, but that has now been amended. And there's a slight amount of patch drift with MRI, which was mentioned in a lot of the Prism talks, which is how in the world do you keep sync with all the patch releases? Which brings us to the next parser we're mentioning, which is Prism, the one parser to unify them all. Now, it takes a fairly different approach again, which is Ripper was very literal and verbose, White Quark was very minimal. Prism tried to combine the two and actually has interfaces on top of it for dealing with these various formats of parsers to be able to deal with them, which is why RubyKaigi got a speed boost out of it. Now, the problem is that this can be very verbose, and while it's very useful for things like the Ruby parser, it may not be as useful for tooling. So as far as the pros we have whenever we're dealing with Prism, we have the unification of all these other parsers as a unified standard, which goes back to the classic, well, if you have 10 standards and you try and unify them all, now you have 11 standards. But I think that Prism does have a very good gain on this and has done a lot of incredible work here. It has comprehensive contextual information, relies very heavily on keyword arguments and of the type of nodes that we're using. It's about 5 times faster than White Quark, and if you run RubyKaigi on, say, a several million line of code Ruby monolith, that takes about 3 to 5 minutes to run that thing and do autocorrections. Imagine if you got that down to a few seconds or even faster in some cases, and that is a very, very real CI build time and improvement there. But it has compatibility layers with White Quark, which means that you don't have to change anything except for some very, very rare niche cases, which they are amending right now. The problems are that because it has comprehensive contextual information, you have to deal with that. You have to be present and know about that contextual information whenever you're writing tools on top of it, which may be a bit more than you really need. It has a lot of nesting and class verbosity to where you have keywords like body that are repeated multiple times as you go down this, and sometimes you have duplicate keyword nesting, which can make it a little bit difficult. That said, I still think that Kevin has done an incredible job getting it to this point and will continue to do so, and I look forward to seeing where it goes. But the big point we need to get to when we're dealing with tooling is ease of use is critical. If you make the most powerful tool in the world, it's not going to matter if no one knows how to use it. So what we care about is the ease of use to make it more accessible to your everyday developer who doesn't care about doing PhD level research on some of this stuff. So while the move to Prism was done to provide full context, given the complexity of Ruby, it makes a lot of sense. But more often than not, do we care about preciseness? Not really. We care about getting close enough to make a decision, close enough to say this code should change, close enough to do a lot of things, such as language server plugins. Maybe we want the preciseness. Maybe we do care about it. Maybe we don't. That could be either way. Automated refactoring also falls kind of in the middle because some areas might need additional contextual or automated upgrades. But if you're doing something such as code search, do you care about the exact format of that code? Not really. You care if it's close enough. Are you doing similarity or fuzzy searching? Did you mean? Are you working with LLMs or AI? Or are you doing any type of work with packwork, which is how do you actually work in a very, very large Rails application without everything running into each other? So I hope to see tools like Prism find a little bit more of a balance in the future, but for now, I think that we have a lot of balance given by these compatibility layers, which affords us a lot of flexibility. So that's all well and good, but where exactly does pattern matching come into the equation? Because we spend a lot of time talking about parsers, but not a lot talking about pattern matching. So for those of you who are not familiar with pattern matching yet, we are doing a short introduction. There are some more detailed articles, and you can find the QR codes as well as code linked below in the chat channel on Discord. for additional examples, but let's just go into a very quick overview of this. So let's start with this code for a quick refresher on array-like pattern matching and pattern matching one-liners. Now, I prefer to call them single branch because oftentimes I will use line breaks and I do not feel bad for this. RubyKaigi might make me feel bad for this, but I will not. I will turn it off. It cannot tell me what to do. Now, this captures many of the core syntax structures and we'll quickly step through each one. At the bottom right, you'll find a QR code which links to the main repository for this code or for all the relevant tools associated with it. So step by step here. The first is that we have a literal array. Now, to anyone who uses Ruby, this isn't too bad. This is just an array with a couple of numbers and a string inside of it. Everything that we've seen so far if we've done any amount of Ruby. But the pattern match is where this gets different, is where we have the keyword in. And everything after in is that pattern and everything that we're comparing to. Every value in this statement uses triple equals, much like a case statement does, but also has some additional syntax we will get into. So the first comparison is with the value 1, and it's matched to an underscore. This means we do not care about that value. If we want, we could name it something like underscore first number, but this is just saying that this is an unused variable that we do not really need to know about. But we do want to preserve the structure of this array and say there should be something there, we just don't care about it. The next is the value 2.0, which is matched against numeric hashrocket in, which is two parts. We'll get into each of those. The first is numeric, which is comparing to the value of 2.0. If that happens to be true, it's going to assign that value to n using right word assignment using that hashrocket syntax, which is the other part of pattern matching. Now, we could get into some detail about the differences between n and the differences of the right-hand assignment, but that will be a topic for a much longer talk. You can see below that n is equal to 2.0, which is our extracted value. And this could additionally just be in if we only wanted to capture that value and we did not want to do any type of checks against it. So for the next value, we're matching a string against a regular expression. Now, when I said anything which happens to use triple equals, I did mean this. Whether that happens to be regular expressions, whether that happens to be a class name, whether it happens to be an IP address, you could even do that. It's fascinating. It'll actually do subnetting, which is really useful, by the way. So it catches if that string happens to start with the letter S, which really demonstrates a lot of the flexibility of some of this feature. Next, we have pin values. Now, if n in the previous area was assigned to 2.0 and it was just n, it would be assigned to 2.0 again. It would be overridden. But what we're saying here is I want that value to be the same. So in this case, we're saying that n should be the exact same as the previous one. This could refer to a variable assigned in the pattern match, or it could refer to something assigned outside of it, which allows us to say that I expect this thing to be the same, which is very useful in some of these cases and will be part of our demonstration later. And last is the star, which captures anything after that point. Or if we put it at the front, it could capture anything before that point. If we put it on both sides, well, it'll try and find that expression anywhere inside of the array, which is very, very useful, and that's called a find pattern. What this is saying is don't worry about the rest of it. I know there's some more values, but I only care about this part of it, whether it be the front, the back, or somewhere in the middle. Now, I appreciate this is a very quick introduction, and I have provided some more detailed explanations on the link as well as some articles I've written on this subject which might be useful to you. If you're not able to get these QR codes, do check the Discord channel because there will be links there. So when working with pattern matching, there are a few additional tools I like to use to make things easier. The first are two helper methods. One to give me the AST of code at the current Ruby version that I might want to match against. And then the second is deep deconstruct, which is I want to know the array representation that I'll be using. And you might wonder, why do I care about having the array if these are already structurally same? Well, we'll get into that in a moment, but it is very useful for the sake of this talk, and I do use it very frequently whenever I'm debugging or writing RubyKaigi rules or other such rules. So to start with a simple example, let's say we could get the AST of 1 plus 2 and its array representation. Not too bad, but what if we had something a little bit more complicated? Like, say this, for example. Some might notice that the block for this code could be shortened, but you see, I'm very lazy. I don't want to do that. I want Ruby to do that for me, and we can. And that's what we're going to do. So say we wanted Ruby to do it for us. How might we go about that? Well, looking back at that AST, and above at its deconstruction, doesn't that right hand with the arrays look an awful lot like what you might be pattern matching against? Couldn't we do something naughty like copy and paste that to the right-hand side of a pattern match? Well, let's give it a try real quick. And sure enough, there you go, it works one-to-one. That's why I like the deep deconstruct method, because I don't have to think about this, I don't have to write it out. I just say deep deconstruct, copy, paste, done. Look, we have a pattern match, we're done, the talk's over. Anyway, joking aside, it's very specific, isn't it? It doesn't really match against everything, it just matches against that one particular shape. We don't care about the one particular shape, we care about the general idea of the shape. So how do we express the general idea? Well, that's what we're going to step through. So first off, we don't really care what the array is, or even that it is an array at all. We care what the receiver of the block is. So let's name that receiver so we can capture that value. And you'll see that at the bottom there, to where we have the captured AST node as well as the source code of it. This gives us back the receiver as a value, and we can even get its original source too using .source. So now we've abstracted to we don't care what this is being called on, we just care what is doing the calling. So what about the arguments? Well, we can switch that over to argname. So what we care about is that the argument that is provided to the block is the same that is being called. So we'll notice that v is being called there with v.even afterwards. We want to make sure that that variable is the same, because if that happens to be v and x.even, we can't shorthand that. That's not how it works. So we need to structurally describe how this is laid out and why that's being called on. But we can still see this is accurate given by the true there. So how about even? Do we care what the method called on it is? No, not really. We just care that there's a method called on it. So let's go ahead and pull that out as well and call it called method. And now we have a fairly generalized match, which allows us to represent kind of the structure. In fact, we could even probably wrap this in a function, and there you go. You have something which is able to tell you whether or not something is shorthandable in one simple method and make our match more generic. Now, we'll get back to some of those other capture variables in a moment, but let's prove that this works first with a few examples. So in the first case, it is shorthandable because we have the same argument name. In the second, it's also shorthandable. We're using reject instead, and x, which is a completely different variable name. This still works. In the next case, we happen to have y plus 1, and while that is a method, which is dot plus, that has an argument, which means this no longer matches our shape. We can't do that. Or in the case of something which happens to have multiple parameters of x and y, that doesn't work either, because we're describing a shape with one argument and one caller, which is receiving this method. Well, you remember that tree rewriter from earlier? Turns out we might be able to use that in order to make Ruby do this for us. We can create a new rule that looks for block nodes, and if it matches our pattern, we can replace that node with our new shorthanded version made from the values we extracted. Now, those who've worked with RubyKaigi before likely recognize a lot of the syntax. Refactor is one of my creations, which is supposed to be a more abbreviated version, because unfortunately code does not fit on slides and only have so much space. So the simplified focus is more on refactoring and upgrades of, I only want to transition this once. I do not wish to alert on this. I just wish to change this. And the change actually happens where we have replace, which is replace that node with the new shorthanded version using the values we've abstracted from that pattern. And we can see that working below where we process 1,2.select v.even, and that does in fact work. So now that you've seen some of the potential of ASTs and pattern matching for kind of manipulating and refactoring Ruby code, let me show you a glance at the future and where this could be going. And some of it, it's already here. So I've hinted at it earlier in this talk, but pattern matching is very exact. What if we could get closer to close enough? Do we actually care about stuff, or do we just care about the shape and that the shape happens to match these things? Say that you had millions and millions of lines of code, like some 5 million line of code repository, which some companies like, say, GitHub or Shopify or Gusto or Square might have these things. And I've worked with a lot of these. And if you happen to have all these database queries where someone is calling something from the person class where they should have no knowledge of that, how do you know how often this is happening? How do you know what arguments they're asking? How do you know anything else about it? Well, we don't really care that the favorite language being asked is Ruby or Python. We care about the shape of it. So how might we be able to express that? How might we be able to anonymize arguments? And it turns out that a lot of this stuff with ASTs, we could potentially just do that. And we can describe a shape in which we don't care about the argument, we care about the shape. And as soon as we know the shape, and as soon as we know that all of these align to certain shapes, we could rewrite rules to replace all keywords positional arguments with this literal underscore, which allows us to then do something like this, to where we say there are 2 instances of this, 1 instance of that, and 2 instances of this other thing, which that doesn't seem very impressive, but in some of the code bases I've applied this to, that happens to be counts of 100, 200, 300 in some cases of these things. And now I know who is calling my code, who is calling my APIs, and what do I need to refactor down into new APIs or new patterns for consumers. Or if I happen to have shipped a gem, I can look at all my consumers and say, they're calling all these methods with these shapes. They shouldn't be doing that, and I intend to refactor this later. What do I do about it? So it gives me a lot of knowledge of being able to say, I care about the shapes of something rather than the exactness of it. Now, imagine we could do this with even fuzzier searches that finds code which is very close on other axes, which would be something like tree edit distance, which is unfortunately very complicated and above my head. So the next, if we're talking about close enough, in an index of all our public APIs, couldn't we just tell people what to use automatically? Well, I don't see why not. Let's say we had a public API, which is something like person.group_favorite_language.count, and we want to know that. Now, if someone else in our code base happens to go and write code which looks very similar to that, could we not say and look at that through a code lens of indexing of this public API exists already, did you mean to use this other thing instead? And that's very possible today using language servers. We could very easily do something like this. Now, how many of you remember tools like Rubular, for instance, which happen to give us a very visual representation of how regular expressions happen to work, of showing us what were the captures, what were the values extracted out of this, what matched, what partially matched. Combine that with local capture groups, and other tools and references, this could become very handy. And Marc-Andre, who's one of the RubyCop core committers, did just this with RubyCop's node pattern, which is a precursor to pattern matching, which gave us a string-like representation of how do you match against this. Now, they've since moved a lot of this stuff over to pattern matching, which has given them some more flexibility and is easier to work with because stringly typed things crash in weird and unusual ways and are not exactly as predictable. But the biggest thing in there you'll notice is closest non-match, which is I don't care about exactness, I care about close enough. And whenever I'm writing these things, I want to know what am I working with, which is incredibly, incredibly useful. And the link in the bottom right does link to this tool, which is live on Heroku, by the way. Now, if we can manage to do this for pattern matching as well, I could see this becoming incredibly useful. Now, let's say we went even further and said, I want to be able to automatically upgrade the gem, like let's say Rails. How many of those upgrades are things like shift this syntax to that syntax as long as it retains the same shape? What if we could just bundle exec gem name upgrade? And that might sound like a novel idea, but Ember.js and other languages have done this for years. Why can't we have it as well? What if we were able to ship gem upgrades with the gems themselves instead of having to have an external tool like RubyCop do this for us? We could potentially take out a lot of the time of upgrading to Rails or upgrading to these brand new libraries. Or let's say that we went so much into the problem of ASTs, it's not very accessible. I mean, even with this talk, you're probably thinking, why would I want to go through all that data and have to learn how to use this? What if I could just say, I have code A, I have code B, figure it out, please do it for me because I am very lazy, and I am. So what if we could have something that could potentially say something like, I have this where it's from, and this doesn't work by the way yet, maybe, and this where I want to go to. I've tried it in the past, but this gets very heavily into tree edit distance, Zhang Shasha, and a lot of PhD research papers on tree differences, and I'm not quite particularly a diligent student or near clever enough to get into that. Instead, we might be able to hint to Ruby that we have some tokens that have to be moved to other locations on a tree and work with that. And after all, we're not using global variables for anything else, are we? I hope not. Well, for as much as I like white quark, it does not consistently nest some structures either, so there are some other things we need to do here. But interestingly enough, towards the end of this talk, I actually had someone mention this interesting tool called Synvert to me, which does exactly this. So I'm very fascinated by this and how exactly this works. And I would very much like to see the underlying code there because that is a very difficult problem. I'd be very impressed with how they solve that. And of course, the subject that everyone needs to mention if they have any talk whatsoever, they're going for any job interview, is AI and LLMs. How does that work into the equation? Well, what if we just ask ChatGPT to do all this stuff for us? Like, I want a Ruby pattern match that matches the AST of a class with a method called testing. So ChatGPT answers me back and says, hey, you should use this handy little thing called Parser. It's going to be very useful to you. Go ahead and install it, and then here's some code which might match against that. Like, well, how accurate could it be? It turns out decently accurate. It does a lot of the manual traversal of this tree, but it got really dang close, and that puts down the bottom. That's all you would really need to shift in order to make this into a tree rewriter. So very potentially ChatGPT could give you most of the stuff you need to do right here, and that might be very worthwhile as an investment to learn how to use some of this stuff. And if that's not enough, it also gave me some sample Ruby code and said, hey, try it with this. This will work. Man, I'm going to be out of a job one of these days. What's going to happen? So I see that as being a far more accessible introduction to some of these tools, which allow new developers to get close enough to where they can do the last mile. And I think that's where a lot of the beauty of artificial intelligence and large language models is going to come in, which is get me far enough to where I don't have to start this from scratch, which I'm honestly probably going to use this for a lot of my rewriting as well, and I could see it becoming very handy. So to wrap up then, I believe in the potential of ASTs and pattern matching to help us build more accessible tooling. But for many of the items looking to the future, I believe the future is already here in a lot of ways. We have a lot of brilliant people, even at this conference, who are writing these tools right now, who've already made great progress on some of those things. In fact, some of them, while I was writing them, I found out that someone else had already written it, which is an amazing thing to do because it means I'm very lazy and I don't have to write it anymore. So where do we go from here? Who knows? But I look forward to seeing it. So if you want to read more of my work or examples or follow along, feel free to find me on any of the social networks. I'm no longer active on Twitter or X, but you can find me elsewhere. And as far as credit, a lot of kudos goes to the Ruby core team, Bubatsoff, all the RubyCop folks, Marc-Andre, Whitecork, Kevin Newton, so many more people that I could ever list here. Because it's never solo effort. This is so many people building so many tools that come together to make something really incredible. And that, to me, is what Ruby is. The future of Ruby tooling is not only technology, but the people who make it possible. We have some really great people leading the way on that. Now, that all said, that's all I have for you today. So thank you for your time. And that's it.